In this video, we're going to talk about inverse function. Function f has an inverse function, which is a notation f inverse. If and only if the function passes the horizontal line test. So for example, this blue curve is a function f, which means that it has to pass the vertical line test to be a function. Now this function f will have an inverse function if it also passes the horizontal line test. In other words, when you draw a horizontal line, at most, it has to intersect at one point. Now let's see whether f of x equals absolute value of x minus 1 will have an inverse function. So first of all, f of x is a function. It passes the vertical line test. Now, does it pass the horizontal line test? It doesn't. You have 2 points that you intersect with the horizontal line. So, unfortunately, f of x is a function, but it will not have inverse. So, answer is no. What about our g of x? It's a polynomial, and it is a function because it passes the vertical line test. Now, does it also pass horizontal line test? Yes, it does. Because no matter where you draw the horizontal line, at most, the intercept is at one point. So g of x will have an inverse, which is g inverse of x. So yes. Now, what's so interesting about inverse function is that, let's say you have f of x and f inverse of x. If the domain is A, then the range of f inverse will be A. And if the range is B, the domain of f inverse will be B. So basically what's going to happen is that domain of f will be the range of f inverse. And the domain of f inverse will be the range of f of x. And we'll look at more specific examples. So now you have f of x equals x minus 1 over x plus 2. And they want you to find the inverse of f of x. So now, in order to find the inverse, remember this is the same thing as y. F of x is the same thing as y. So y equals x minus 1 over x plus 2. So if you want to find the inverse of f of x, what you need to do is, remember, domain and range interchanges. So instead of y, you got to put x. And instead of x, you got to put y. And now what you got to do is you need to use algebra 2 to solve for y. So let's cross multiply. You'll get x times y plus 2 equals y minus 1. Let's distribute the x. And let's put all the y terms together. So xy minus y. And put 2x to the other side. Now let's factor out the y. And let's solve for y by itself. So you end up getting negative 2x minus 1 all over x minus 1. So now y by itself. So the inverse of f will be negative 2x minus 1 all over x minus 1. So now we have f of x and f inverse of x. Let's see what happens when you plug in 0 for x over here. Now let's see what happens when x equals 1. When x equals 1, you get 0 over 3, which is 0. Now let's plug in 0 for x, which was our y value for f of x. So for inverse of f of x, we're going to plug 0 here, and you end up getting positive 1. And notice the x and y interchanged. Okay, what about 2? Let's put 2 for x over here. then you're going to get negative 4 minus 1, negative 5 over 1, so you end up getting negative 5. So 2 negative 5. Well, let's put negative 5 for x and see what we get. Negative 5 minus 1 is negative 6 over negative 3, which is positive 2. So again, these two functions are inverse, and look at the domain and the range. They interchanged. The x value becomes the y value, and x value over here becomes the y value. And let's find the inverse of f of x. So using the same procedure, put y equals radical x minus 4, and interchange x and y, so you get x equals radical y minus 4, and now all we got to do is solve for y. So in order to solve for y, you need to square both sides to get rid of the radical. And then you have to get rid of negative 4, so you end up getting x squared plus 4 equals y. So therefore the inverse of f of x will be x squared plus 4. So again, let's see what happens to our domain and range of f of x and f inverse of x. So when x equals 4, you know that the y value of f of x will be 0. So what happens when you plug in 0 for x? You get 4. What about 13? When x equals 13, it's going to be radical 9, which is 3. When x is 3, 3 squared is 9, 9 plus 4 is 13. Okay, what about when x equals 1 over here for f inverse? Then you get 1 squared, which is 1, plus 4 is 5. So that means when x equals 5 over here, 5 minus 4 is 1, and radical 1 is 1. So again, two functions are inverse to one another if the domain and range interchanges.